Awesome. So first off, I just wanted to say thanks, Justin, for that introduction. And also thanks for calling us experts. I think speaking for myself, I don't think I'd consider myself an expert in this field, just given how relatively new this entire process is and how we're all kind of just learning as we go currently. But yes, I think it's important, as Drew was mentioning, just the whole idea of including MEP systems in the embodied carbon calculation and the impact it has in the overall carbon landscape that we're dealing with. So I just wanted to introduce myself. I'm Ivan. I'm a building performance analyst with McKinstry. I've mostly been doing energy modeling most of my life, but have been transitioning to really think about more on the whole, on carbon as a whole. So thinking about just the embodied carbon of mechanical systems and how we can incorporate that in some of our analysis. So I'll go over the tools and processes we've used in some of our studies when looking at MEP embodied carbon. So kind of thinking about the workflow of the process, it's very similar to what you would have when doing an embodied carbon calculation for structures and enclosures. So the first being just defining that scope, what you're kind of including in the material takeoffs and what you're thinking about when doing your carbon calculations. And then the second step being those material takeoffs. And then third step, gathering all of the LCA data for the different material and components that you're including, and then compiling the results and reporting on them. So I'll kind of go into detail on all of these steps in the workflow process. Cool. So thinking about the scope of MEP embodied carbon can be a little bit of a challenge. Just thinking about what you're including. Are you only including mechanical systems and components? Are you also including the electrical components and the plumbing components? So just trying to understand what the scope is. There's no real standard around what we're including right now. So when we're doing a lot of this work, a lot of the times it's for a study. So we're trying to create that boundary ourselves. So right now it's just trying to figure out what we're trying to include and what we're excluding in that. And a lot of it can be defined by where the project is. If you're doing a shell and core project, you might only be including shell and core mechanical systems and not TI mechanical systems because TI layouts haven't been completed yet. So just understanding the projects you're doing this kind of study on and where they're at, and trying to do the best you can to include what you can when thinking about embodied carbon. The other thing I wanted to talk about is just what LCA stages you're including when doing embodied carbon calcs. So typically, I think when doing ILFI embodied carbon calculations, you're including A1 through A5 of the embodied carbon. For MEP components, it can be a challenge to get all of those things. So I'll go over an estimating methodology developed by CIBSE in a little bit called TM65. But yeah, just trying to include everything that's in that embodied carbon life cycle stage. Great. So now thinking just about the material and equipment takeoffs, a lot of us are familiar with Revit and using BIM models to kind of get all of that information. It helps automate some of that process. So just trying to engage some of the information we have in our models to get the material and equipment quantity takeoffs, and then just trying to figure out ways to categorize those materials so that when you report on that data, it makes it a little bit more interesting when putting it together. And then getting into that LCA data. So Drew kind of alluded to this with the MEP 2040 challenge. The gold standard right now is being able to have an EPD for a mechanical component or electrical component. EPDs are, product specific. They're verified and they're researched, and just having that carbon coefficient from an EPD is a lot more useful than using an estimating method. So again, we're trying to push more vendors and manufacturers to provide some of this information to us. So there are different databases you can go to find EPDs. There's Quartz that I've used. Yeah, so anyway, you could find EPDs on Google if you have a specific product that you're looking for. And then if you don't have EPDs, you can use the A1 data from the raw material of the product. So if you are looking at steel, you can find the A1 for that, and then use the TM65 method, which I'll get into, to estimate your embodied carbon. So getting into that TM65 method, this is a little bit of a workflow chart showing how to do your embodied carbon calculation if you don't have an EPD available for the mechanical, electrical, plumbing product that you have. Then you can kind of get into this TM65 method. First step, trying to get information from the manufacturer on the raw data, and then just using a mid-level or basic calculation method to do the estimating of the embodied carbon of that MEP product. So what that exactly looks like is you have this basic form that you would provide to a manufacturer of the product, where they would report on that product's weight, the different materials that might exist in that product, and the percentage of that material of that product, and then send that over to you. So the first step would be to get this data from the manufacturer, and then get the A1 or material extraction of that raw material. And then the second step would be to use, the third step would be to use scaling factors to get the A2 to A4 of that product. And again, that's just estimating, because we don't have that data readily available if you don't have an EPD. The fourth step would be to include a buffer factor, just given the simplicity and kind of averaging that we're doing in this process. We just want to make sure we're being a little bit more conservative. And then the final step is just to include the refrigerant leakage to get the full embodied carbon. So again, this is probably the process that we're using a lot, just given the limited information we have on embodied carbon for mechanical, electrical, and plumbing products. So it's a great resource. The TM65 is what we've used in a lot of the studies that we've been doing. So again, it's just a good way to do your estimation process when you don't have that data readily available. And then just reporting on the results. Here are a few of the studies that I've worked on. The top being a study that we did for an office TI space. So the scope was limited to just the TI of the office, looking at the low pressure, medium pressure duct distribution network, the chilled water and hot water pipes, and the terminal equipment. So just looking at the impact of the TI equipment and comparing that relative to that CLF study that Drew was mentioning on MEP systems. And then looking at the distribution of what we're looking at, the majority of it being in the ductwork. And then we have pipes and equipment after that. And again, this is limited to the TI scope, so this doesn't have the refrigerant that would exist if we had a central plant with an air source heat pump or something of that nature. So that's the top study we did. The bottom study we did is actually not something I worked on personally. It's something I kind of sponsored as a UW capstone project, where a bunch of students at UW looked at the population health building and looked at its baseline mechanical equipment. And we kind of challenged those students to think about alternative mechanical systems and how that embodied carbon would look like. So the students did a full embodied carbon calculation of those systems using the TM65 method, and found that the baseline, which was a fan coil unit, was kind of that mid-level. The VRF, which is surprising to me, because I feel like there would be a lot more refrigerant leakage there, was the lowest. And then the highest was that radiant heating and cooling. And that was the highest, just given that we included the concrete associated with the topping slab and all of the pipes that would need to go in for a radiant slab system included in there. So that kind of bumped up the embodied carbon of that system. So that kind of wraps up the process that we've used in some of our studies. I'm sure there are different methods and different ways people have done it before. And again, this is kind of a new process for a lot of people. So be curious to hear thoughts on or opinions on anyone might have after the presentations are done, and I'll stick around. So if you have any questions, feel free to reach out.